All right, welcome back. We're doing parent function number 9.
This one's called the greatest integer function, and the equation is really f of x equals, and it's this funny little symbol that looks like an L, and it kind of means round down. If you've had FST, you've seen this symbol before. You did touch on it briefly in Algebra 2. The anchor points, this one, we've got at least 6 anchor points because there's some weirdness going on. But basically all it means, Mr. Lecky's going to write our anchor points while I talk. All it means is, as you plug in any value for x, you need to round down to the next integer. So if I plug in x as 2.5, I'm going to round down to 2. Okay?
But our anchor points are just going to be integer points.
Yeah, which is why you really need to know what the shape of the function looks like. Because if you just graph the anchor points, you're going to think it's a line, and it's not. So here are the anchor points Mr. Lecky's graphing. But again, let's take, for example, what if you have a 0.5? Well, if you have a 0.5 and you plug it in, you're going to round that down to
0.
0. Okay?
So everything between 0 and 1 gets rounded down to 0. And we end up with a whole at positive 1.
Yep.
And then it moves up to 1 on the y-axis.
And I think you mean an open circle there instead of a hole, but yes.
There we go.
Because we can't just plug it with 1 point. And it's going to be constant on these little steps. Sometimes this is also called the step function. Okay? And that's it. That's what it
really
looks
just
like.
looks like a staircase.
Goes left and right forever. Okay.
Yeehaw.
Notice that when it's open on the bottom step, it's closed on the step above it. If it was closed on both, it wouldn't be a function. So the domain's going to be all real numbers, or from negative infinity to infinity. The range is a little bit interesting because we are leaving out. We will never have an answer that's a decimal. So what's the funky Z, Mr. Legge? You're making stuff up.
That means just integers. Do they have to know that?
They don't need to know that. They could just list it. Okay?
How about we do it this way?
Dot, dot, dot. -3, -2, -1, 0, 1, 2, 3. Dot, dot, dot. Okay, that just means dot, dot, dot means continue forever in that pattern. So, or you could write down the integers. We would take that as well. All right, symmetry, there's no symmetry. It is not bounded. And there are no asymptotes. But we have lots of discontinuities. In fact, we have discontinuities at every single integer. So they are non-removable discontinuities at the integers. All right. It's not actually increasing or decreasing, but it is constant on every little step. So we want to say constant
between the
integers. Since it's constant, there's no extrema. But we do have some end behavior. So the limit, as x goes to negative infinity, of round down x, I don't know any other way to say that.
It's a floor function.
A floor function, thank you, is negative infinity. And the limit, as x goes to infinity, of that same function, notice I didn't say it, would be infinity. That's it. We'll do a little stretching and shrinking with this later on in the chapter.
That'll do it for number 9.